This is Pre-Calc section 11.5, partial fraction decomposition, and I'm going to show you a method that we call equating coefficients instead of at the end choosing values to let x equal, and I will show you why when I get to that page. The first thing you should notice is that we're looking at irreducible quadratic factors. X squared plus 4 inside that parentheses cannot be factored. Furthermore, we've got a power right here, which means these are repeated factors. First denominator will be x squared plus 4 to the first if you want, and the second will be x squared plus 4 squared. Remember, this is what we did when we've got the same factor repeated. You have to build up into the highest power that you have right there, which is squared. The thing we've got to look at is decide what the numerator is. Remember, when you have an irreducible quadratic factor in the denominator, your numerator is going to be of this form: ax plus b. Because this is a quadratic factor, we need our degree in the numerator to be 1 less than this degree. This is x squared. So this is going to follow the same format, but it's going to be letters we haven't used yet, cx plus d. The next step is going to be to multiply by the common denominator, which is this denominator right here. So that's what I've got on this page. This is all set up to multiply by that common denominator. When you multiply over here by x squared plus 4 squared, we're going to wipe out that denominator entirely, and we have x squared plus 2x plus 3. Over here, the common denominator is x squared plus 4 squared, but this denominator is only x squared plus 4. So that when I get rid of x squared plus 4 here, this is only going to cancel out with one of those, so I'm covering up the exponent. So what's left is, in parentheses, ax plus b, it's in parentheses because it's a binomial, times, in parentheses, x squared plus 4. Plus, same process here, I want to eliminate this denominator, which is identical to this denominator, so I can just wipe those out from here, and what is left is just cx plus d, which I can put in parentheses or not. It's not being multiplied by anything. I'll just continue with the rule. If it's a binomial, we'll put it in parentheses. Now, what we've done before is we've said let x equal blank, 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 blank. Well, because these are irreducible quadratic factors here, setting up and saying let x equal something is going to make this very tedious because we don't have any linear factors. When you had linear factors, it was easy to pick a number like a 1 or a 2 or a 0. This would be more complicated to do that. So instead, we are actually going to FOIL this out. If we FOIL this, this is going to be ax cubed plus bx squared plus 4ax plus 4b. That's just doing our FOIL, plus cx plus d. Now I want to organize this in descending order, which it starts out that way. This is ax cubed plus bx squared. Those are the only cube and squared terms. But we've got 4ax, cx. Both of those have an x in the term. So I'm going to put plus 4ax plus cx. And then these are my plain old constant terms because there's no variable with them. The next thing I want to do is clean this up just a teeny bit. So we've got ax cubed plus bx squared plus, I'm going to factor an x out of here, x times 4a plus c, and then the 4b plus d just kind of tags along at the end. Now, over here, this is x squared plus 2x plus 3. This method we're going to use is called equating coefficients, and what that means is I'm first looking at this ax cubed. Is there an x cubed term over here? There is not. So I could think about this as if it were 0x cubed. So the coefficient on 0x cubed is 0. The coefficient on ax cubed is a. That tells me my a value is 0. Come to the next term. This is 1x squared. This is bx squared. These terms are both x squared terms, and those coefficients must be equated. So the coefficient on the x squared term over here is 1. The coefficient on the x squared term over here is b. So right away, we've got that b is 1. We've dealt with the cube, we've dealt with the squared. We're down to the x term. The coefficient on this x term is 2. The coefficient on this x term is that binomial, which is 4a plus c. And you think, uh-oh, we've got two variables, but we're okay. We already know that a is 0. So right here, I can plug 0 in for this a. 4 times 0 is 0, that's gone. That gives me that c is 2. The last thing I need to look at is the coefficient here of the last term, which is just the constant term. So instead of calling it the coefficient, the constant term is 3, which is equal to this constant term, which is 4b plus d. Same thing I did a minute ago. I know that b is 1, so I'm going to substitute in 1 for b. 4 times 1 is 4 plus d. Subtract 4 from both sides gives me that d is negative 1. So I found those coefficients, I found those values for a, b, c, d pretty easily by equating coefficients. So I have this partial fraction. I have x squared plus 4, that was my first denominator, and I have x squared plus 4 squared. And all I have to do is go back to my top part up here, filling in the a and the b and the c and the d. So a is 0. So this is 0x plus b, which is 1. Well, that's kind of silly to have a 0x. I just wanted to show you what happened. Get rid of that, and all I have is 1 over x squared plus 4. The numerator on this x squared plus 4 squared, this up in here, is cx, which is 2x, plus d, which is plus negative 1, which is okay, but it would simplify into just minus 1. So this is the partial fraction decomposition for that original polynomial. Can we use the method of equating coefficients on some of those previous problems from earlier videos? Sure we can. I could do the exact same steps over here. This is an older problem that we've already done. We've already cleared out the denominator. And on the method where we are plugging numbers in for x, we did not have to FOIL this out. We chose these numbers, 0, 3, and negative 1, because of these denominators. And those were good ideas because when I plug these in, a lot of stuff goes away. That's why we did x equals something, x equals something, x equals something. If I wanted to do that same method of equating coefficients, I would need to FOIL this out, multiply it times x, distribute this, go back and combine my like terms, and then equate the coefficients. So is it permissible to use the equating coefficients method? Sure, but when you're dealing with a lot of linear factors, it's a lot easier to just let x equal particular numbers that would create the zeros for you.